Okay, hi, my name is Muhammad Ikmal Hakimi.
And hi, my name is Muhammad Arshad bin Zainal. So we will show you a video about a simple understanding about sorting. Please enjoy the video.
Okay, I will start explain the definitions of sorting. Sorting is an operation that segregates items into groups according to specified criterions. As examples, they have A, so we can see the numbers is on the unsorted. So the second one is A in the sorted one, because it will start with the minimum number first and then it will lasting with the biggest number on the right side. Okay. Sorting is equal as ordering. Sorted is the data that have been ordered based on a particular way. Example of sorting is such as the words in dictionary, files in directory, and the index of a book. The next one is complexity. Complexity is to measure the algorithm efficiency in internal factors such as the time needed to run an algorithm. And then the external factors which is not related to complexity are size of the algorithm, speed of the computer, quality of the computer. Most of the primary sorting algorithms run on different space and time complexity. For the time complexity is defined to be the time the computer takes to run a program, as in our case is algorithm. And for the space complexity is defined to be the amount of memory that computer needs to run a program or the algorithm. Okay, as we can see, there are three forms of algorithm, and how the rate of growth of it. And then the type of sorting algorithm, we have a bubble sort, selection sort, insertion sort, and merge sort. Okay, for the first one, bubble sort. The idea from the sort is a bubble in the water. How? When a bubble moves upwards, the water from above will move downward to fill in space left by the bubble. Bubble sort compares the numbers in pairs from left to right. The left side number must be the lowest number and the right side number must be the highest number. Okay, as we can see, this is the one of the example how the bubble sort works. Okay, we can see from the first lanes 40 and 2. So 40 is the biggest one, so it will move to the number one space, to the number one place. And 43 and 3, 43 is more biggest, is bigger than 3, so it will move also. And 65 is the biggest than all of these number, 0, -1, 58, 3, 42 and 4, so it will move to the left sides. And row 2, we can see it's also same as for the 2 and 1. The 2 will move to the one place. And then 40 and 3, it will move, 40 will move to the third place with swap, then it will swap the place. And 43 and 0, 43 will swap the place to the -1 place. And 58, it will swap to the 4 place, because For 58 is the most biggest compared to the three numbers, and it will continue until all of these are in the correct positions. We can see that at this last line, the 8 lines, we can see that the right side is the negative one, which is the lowest numbers, and the left side is the 65, which is the biggest numbers. And for the real life application, we can see when the students are standing randomly in front of their teacher, and they need to stand in the order based on their height. So as we can see, they are swapping between them until they are sorted according to height. This is also we can see from at the assembly at the school. Okay, the second type of the sorts is a selection sort. The idea is have a sorted and unsorted group. Initially, all items are in the unsorted group. The sorted group is empty. The item in the unsorted group unsorted, and keep item in the sorted group sorted. We will select the best, which is whether smallest or biggest item from the unsorted group, then put the best items at the end of sorted group. We will repeat the process until the unsorted group becomes empty. Okay, as we can see, this is the example use the best item as the biggest item, which is they will start to find the best item as the biggest item. Okay, as we can see, firstly they find the 65 because 65 is the biggest one, so it will swap the place with the number 4 to the right side to the sorted group. And then 58 is the biggest one, and then it will move to the sorted group, which is the blue one. And 43 is the biggest one in the unsorted group, and then we move to the sorted group. 42 is the biggest one, but it's already at the place for the sorted group, and it will continue until the last one, which is when all of the numbers are in the sorted group, which is start from the negative one, which is the lowest number, until the 65, which is the biggest number. Okay, firstly we will initialize the elements, which is integer I, j, integer a length. Okay, second one is for I equal to 0, I less than a length minus 1, I plus plus, which is we want to use the I less than a length minus 1 is which one, because we want to know, because we use the minimum elements, which is the lowest element in the unsorted group, we want to find it. And then integer j min equal to I, which is the I element is equal to j minimum. For j equal to I plus 1, j less than a length, and j plus plus, which is a test against the element after I to find the smallest one. And if j is less than j min, so it will find a new minimum, and it will remember the index. And if a j min is not equal to I, so it will swap. So there was a simple of implementation of selection sorts in the coding. And for the real life implementation, we can see when we want to pluck the apples from the tree, we can see all the apples on that tree, and we pick the biggest one first, then we will drop the apple in the sorted manner.
Okay, we go to the type of algorithm, which is the insertion sort. So the idea, which is it have sorted and unsorted group. Initially all items are in the unsorted group. The sorted group is empty. The items in the unsorted group unsorted and keep items in the sorted group sorted. So pick any item form, then insert the item at the right position in the sorted group. So repeat the process until the unsorted group become empty. So we take a look at the example. If the left position must be the lowest item and the right position must be the highest item. So the blue one is the sorted group and the grey one is the unsorted group. So we take a look at the first row. The left side, from the left side, which is the 40. Beside 40, we got 2. So 2 is lower than 40. So 2 will move to the left side of 40. So second row we got 1. 1 is lower than 2. So 1 will move to the left side of the 2. And the third row we got 43. So 43 is basically bigger than 40. So 43 will stay there. So the process will be repeated until all of the element is sorted. So the left one will be the most less value and the right one will be the biggest value. And then we take a look at the first row. The first row, the unsorted element is 3. So we have already the sorted 3. So we just put it at the back at the right position of 3. So there will be 3 element. So the output will be -1, 0, 1, 2, 3, 3, 4, 40, 42, 43, 58, 65. And then we take a look at the implementation of the insertion sort in the Java. So firstly we have public class pattern, and then the main method, and in the main method we have unsorted integer array that we have 32, 23, 45, 87, 92, 31, 19. And then the insertion unsort, where we print the integer array after sorting and before sorting. Then public static void insertion sort. We have for loop statement here. In the loop we have int I equal 1, I less than unsorted dot length, and then I plus plus, and then integer current equal unsorted I, and then integer j equal I. That's all is for initialize. And then we create the coding below is to create the right place by moving the elements. So it is while and j is bigger than 0 and unsorted j minus 1 is bigger than current. And then so the for the moving part for the coding is unsorted j equal unsorted j minus 1, and then j minus minus. And then when it found the right place, and it will and it insert now. So the coding is unsorted j equal current. So the output will be as shown below. which is 19, 23, 31, 32, 45, 87, and 92. So to make us more understand, so we take a look the real life implementation of the insertion sort, which is when a tailor arrange the shirt. So they always keep them in sorted order of size, and then they will insert the new shirt at the right position very quickly by moving the other shirts forward, which is the forward is in the diagram is the left side, and to keep the right place for a new shirt. So the diagram we see the 43 is keep on the most right because it is not sorted yet. So the left side, the 45, 44, 46, 48 is already sorted accordingly to the size. So we take a look at the next algorithm, which is the merge sort. So the idea is it have two main steps, which are divide and conquer. It divide array into two halves. It sort each half. Left position the lowest item and the right position is the highest item. It merged two halves to sorted whole. It sorted two halves by compare an item from every half. The lowest will be put first at the left position. And then we take a look at the diagram. We have algorithms. We have algorithm to sort. So the second row it divide into two halves, and then each half it will sort in their halves, and then it will merge together. So to get the merged and sorted array, need to keep track of the smallest element in each sorted half, and then insert smallest of two elements into auxiliary array and repeat it until done. So we take a look into diagram for more detail. So the first one, we have two divided half, which is for the first one is AGLOR and the second one is HIMST. Both half is already sorted. So we must compare the first element of both half. For the first half we have A, and the second half we have H. So the smallest one is A compared to H. So we put A into the auxiliary array. Number 2, the first half we take G. The G need to compare with in the second half. We choose G because A is already sorted into the auxiliary array. So the second half, which is we remain H because H isn't sorted yet. So we compare H and G. So we choose G because G is smaller than H. And then the third one is we choose L in the first half because G is already sorted into auxiliary array. And then in the second half we still choose H to compare with L because H is not sorted yet into the auxiliary. So we compare H and L, and H is smaller than L, so H will be in the auxiliary array. So the process will be repeated until it's done. So we take a look at number 9. So number 9, the first half is already exhausted, so we take a look at the second half. And the second half we have left with two elements, which is S and T. So between S and T, S is the smaller value, so S is smaller than T, so we put S in the auxiliary array. Then number 10, and then we put T in the auxiliary array. So this is the implementation of the merge sort in C language. So we have void merge sort, which is function to sort the subjection A I.j of the array A, and you have if statement, which is j, if j is less than or equal I, it will return the subjection is empty or a single element. And then int mid equal I plus j divided by 2. And then the left subarray is A I mid, and the right subarray is A mid plus 1 dot j. And then we have merge sort I mid A odds, which is the sort of the left subarray, and then merge sort mid plus 1 j A outs is the sort of the right subarray. And then we have int pointer left equal I, which is pointer left points to the beginning of the left subarray, and int pointer right equal mid plus 1, which is the pointer right points to the beginning of the right subarray. And then in k, which is k is the loop counter. And then we have a for loop here, where the loop from I to j to fill each element of the final merge array. So we have if statement in the for loop, j is the left pointer has reached the limit, and as if we have the pointer right, where right pointer has reached the limit, and then as if the pointer left, the A array pointer left and A array pointer right, which is pointer left point to smaller element, and then else the pointer right points to the smaller element, which is outs k equal A pointer right. And then we have the for loop, which is to copy the element from outs array to A array, which is A k equal outs k. And then we have the remaining coding to print the number element, and to enter the integer, and then to print the sorted array, and to return the 0. That's all for the merge sort implemented in C language. That's all from us. Thank you.